Good morning, sir. My name is Shruti Jari, and my topic for today's presentation is sum of subset problem and graph coloring. So, let us understand what is sum of subset problem. This problem we have given a set of integers and also the targeted sum. So, we have to select such integers from the set of number such that their sum is equal to the targeted sum. So, here is the example of targeted sum, that is, we have given a targeted sum as a 10 and we have to choose the number from this array so that the sum of that integer is 10. So we can clearly see that 7 plus 3 equals to 10 and 5 plus 3 plus 2 equals to 10. Second, the graph coloring. In this problem we have to color the graph in such way that no two adjacent region or vertex have a same color. Talking about its algorithmic solution for both of the topics like sum of subset problem and graph coloring. So talking about the first, there are three main algorithmic solution like divide and conquer, dynamic programming, backtracking. So we have to focus only on backtracking in this presentation. So talking about its case study, so there is a scenario like in a company we have to making a project having their own budget. So we have to complete the task in a given budget. So such problem can be solved through this sum of subset problem. Second is graph coloring. So imagine a scenario where we have to make a timetable for a student and such that no no such condition occur where the teachers have given a same classroom at the same time. Here is some algorithm for sum of subset problem, and we have given us steps to solve them. Understand the whole algorithm with the example. So we have given an array of 4 numbers like 3, 4, 5, 6, and we have targeted sum as 13. So let's start with the index let's start with a 0. We can include 3 or we cannot include 3. We have two options. So when we include 3, we can also include 4. We include 5, but if we include 6, the number obtained it will be greater than the required sum. So we will backtrack on when we obtain 7 as a sum, we add 6 in that, so the sum obtained is 13. So our first solution, we get our first solution. After that, next topic is algorithmic solution for graph coloring. Here I have mentioned the steps. We will understand those steps with the example. So here is a square with the 4 vertex. We have to color the vertex such that no two vertex will have same number. So we can color vertex 1. We have to choose one vertex as a starting point. After choosing one, we can color the one as 3 color, as we have chromatic number 3, means minimum color required to solve this graph is 3. So we have 3 options to color the vertex 1. So after coloring vertex 1 as a red, we have 2 options to color the vertex 2, as we have used one color earlier and no adjacent vertex have a same color, such that after coloring 2 as a green, we have 2 options to color the vertex 3 as 1 and red and blue, because vertex 3 is not the adjacent of 1, so we can use the red color. According to this, we can find our solution, and the chromatic number obtained is 3. Conclusion, we can see that how the sum of subset problem and graph coloring help us in our day-to-day life, how it solve the problems like making a timetable or scheduling it, resource allocation, and sometimes in the finance. So thank you.